Down there, life continues. The traffic is awful, stocks go on trading, and Star Trek is still showing.
Good day, grade 9 learners, and welcome to today's Natural Sciences lesson. My name is Mr. Sianda Madala, and this lesson is proudly brought to you by the Gauteng Department of Education. Right, we are in our term 3 and exploring the knowledge area, energy, and change. So today's topic is on forces, and specifically on forces, we'll be talking about non-contact forces, which are also known as field forces, right? That is our topic for today, non-contact forces. So let's quickly look at our lesson objectives for the day. So these are the following things that we should achieve by the end of this lesson. So when this lesson ends, we need to be able to define force, right? We should be in a position where we can be able to define force, to tell the next person what force means or what is a force. Also, we need to be able to identify the unit of measurement of force. Not only that, we need to be able to calculate for force or weight, right? And not only that, we need to be able now to name and describe non-contact forces, right? Including their examples, right? And all this information is found under the CAPS document on page 72. Right. Now let's look at what we have done before, right? Because in order for us to know where we are going, we need to be able to know where we come from, right? So now looking at our pre-knowledge, in grade 5, we discussed energy and movement, right? Then in grade 7, we talked about the force of gravity, which is also an example of a non-contact force, right? Then in grade 8, we talked about atoms, right? Atoms as building blocks of matter. And matter is anything and everything that occupies space and has mass, right? So these atoms are these tiny building blocks that make up matter, as discussed in grade 8. Right. Now let's look at the important terms that are in this lesson. The first term that you come across there is force, right? So a force is an action that can be described as a push or a pull and as well as a twist on an object, right? That's what a force is. When you are pushing, when you are pulling on an object, you are applying force. Then we have Newton. Newton is the unit of measurement for force, right? It is the unit of force and it is the symbol N, right? Also, we have contact force, right? Which is the topic that we were engaging on the last topic, right? So contact force is the force that is exerted when two objects touch each other, right? Then we have field force, and field force is a force that is exerted over a distance, right? So field force is a synonym for non-contact forces, right? So it means what? Non-contact forces are also forces that are exerted over a distance without the objects touching each other. Then we have gravitational force. Gravitational force now is the pulling force that bodies exert on each other over a distance due to their masses. Then we have magnetic force. And magnetic force is the force that two magnetic material exert on each other over a distance, right? So note one thing that they keep on saying over a distance, right? Meaning the objects do not have to touch each other. Then we have electrostatic force. And electrostatic force is the field force that arises through differences in the electric charge of objects. Now let's engage on our baseline activity and test our knowledge so far, right? So it is 4 questions, meaning I'm going to give you, because number 4, it needs 3 examples. I'm going to give you 5 minutes to complete this activity, right? But firstly, let's go through the questions together. Number 1, define force. Number 2, write down the SI unit of force and its symbol. Number 3, List two main types of forces. Then number 4 says list 3 examples of contact forces, right? That's all for your baseline activity. And do not forget our WhatsApp number in which you can send in your answers, ask any questions regarding this lesson, or send any comments, right? Our WhatsApp number is 079 578 2908. So now let's meet again after 5 minutes and we shall mark together after that. Welcome back, grade 9s. Now we are going to look at the solutions together, right? Number 1 was saying define force. Number 2, write down the SI unit of force and its symbol. Number 3, list 2 main types of forces. Number 4, list 3 examples of contact forces, right? So the answer for number 1 is what? A force is an action that can be described as a push or a pull on an object, right? Then number 2, the SI unit is newtons, right? And the symbol is N, right? It's newtons and the symbol is N. Then number 3, the 2 main types of forces are contact forces and as well as non-contact forces, right? Contact forces and non-contact forces. Then the examples of contact forces, they include tension force, compression force, and as well as frictional force, right? So I'm going to give you just a quick minute to copy down these corrections. Then after that, we shall move on with our lesson. Welcome back again, grade 9s. Now let's move on with our lesson. Right. Forces, right? We said that a force is an action that can be described as a push or a pull on an object, right? And now we find out that there is 2 main types of forces. We have contact forces and non-contact forces, right? So contact forces now are the forces that act when 2 objects are in contact with one another. When they are touching when they are touching one another, that is a contact force, right? There is contact between the 2 objects, right? So for instance, in order for you to be able to push a wheelbarrow, you need to be able to hold and touch the wheelbarrow in order for you to be able to push it around, right? That is a contact force. There needs to be some contact. So non-contact forces, which is our daily meal today, right? Non-contact forces, these ones, they can act over a distance, right, without the objects touching each other. They are able to push or pull each other over a distance without the 2 objects touching each other, right, which is what we're going to talk about more today, right? So as I've said, that these non-contact forces now, they produce their effect through space, right? They produce their effect over a distance. The objects do not need to touch each other for the force to act, right? As the statement says here, non-contact forces produce their effect through space without the objects touching each other. And these non-contact forces are also known as field forces, right? So sometimes when you read about these non-contact forces, you might find the terminology field forces, right? You might find the term field forces. Field forces is a synonym of non-contact forces, right? They exert their effect over a distance. Are we together? So examples of non-contact forces, they include gravitational force, magnetic force, and as well as electrostatic force, right? These are the 3 examples that we're going to talk about for today under non-contact forces and see how they produce their effect through space, right? Over a distance without these objects touching each other. starting off with gravitational force. Right. So have you ever wondered why sometimes you throw up a pen or any object, then it comes back down, right? This is because of the gravitational force that is exerted by the celestial bodies on objects, right? It pulls everything down towards the center of the earth. So this gravitational force, it is a force that acts between two celestial bodies or two masses, such as the moon and the earth, right? It happens between the moon and the earth, right? So the earth has a gravitational pull on all objects on its surface or close to its surface. It pulls everything down towards the center of the earth, right? So here is the pull between what? The earth, right? The earth and the moon, right? There is a gravitational pull between these two bodies here, right? The earth and the moon, right? So it is an attractive force that pulls objects together and towards what? The center of the earth. And it is also known as the earth's gravity. Are we together? Right. So now, think of this pulling force that pulls everything towards the center of the earth, right? So it has an effect what on where? On falling objects, right? So gravity causes objects to accelerate what? Downward, to build up speed as they go down, right? So here we have an example, right? An elephant falling from a building, right? What happens now? As it goes down, what makes it to fall down even, right? It is the pulling force that we're talking about, right? The Earth's gravity, right? So as it goes down now, it builds up speed as it goes down. It accelerates downwards, right? So now, in that situation of having objects falling down, right? There's also what we call air resistance, right? Let's look at this example. So air resistance is the fluid friction, right? Which acts in the direct opposite what? Opposite to the motion and reduces acceleration of these falling objects. So let's say now you're doing some skydiving, right? And you're using what? A parachute. That parachute enables what? The air resistance for you to be able to float as you are going down, right? So that you do not accelerate to a point where you fall on the ground and break all your bones. Are we together? This prevents what? The acceleration, right? It reduces acceleration as it promotes this air resistance, right? Which is the fluid friction that acts in direct opposite to the motion. Are we together? So objects, when they are falling, they build up speed as they go down, right? So we say that gravitational force has an effect on falling objects, right? As we said that it causes these falling objects to build up speed, right? And it increases its speed at the rate of 10 meters per second every second. Altogether, looking at this example again, right? This person is falling from the sky with his bags of money, right? So the more he goes down, the more the speed he builds up, hence the greater the impact when he hits the ground, right? All this is governed by this pulling force that we're talking about, the gravitational force that is exerted by the moon and the earth on objects. Are we together? So the longer the object remains falling, the greater will be its final speed when it hits the ground. Hence, also the greater the impact when it hits the ground, right? From the highest point going down, the greater the impact and the higher the speed to have encountered as it reaches the ground, right? And this is all called what? Gravitational acceleration with the symbol G, right? So take note of this symbol G. We're going to use it in our calculations as our learning objectives say that you're going to calculate for weight, right? So gravitational acceleration has the symbol G, right? So now how can we determine the size of gravitational force, right? Gravitational force now is governed by distance and mass. Are we together? So now, the gravitational force that two forces exert on each other becomes smaller if we move the objects further apart, right? Let me repeat that. The gravitational force that two forces exert on each other becomes smaller if you move the objects further apart. So for example here, right? If you move away from the classroom wall, the gravitational force that the wall exerts on you becomes smaller. At the same time, the gravitational force you exert on the wall becomes smaller. This is what I mean here, right? So remember that the force of gravity acts on all objects, right? Including you and I, right? You try to jump up, you come back down because of the pulling force that the earth is exerting you as an object, right? So now, I said that this gravitational force is governed by mass and distance. So now, if the mass of an object increases, right, the force of gravity also increases, right? Meaning the pulling force becomes greater as well, right? The pulling force acts what? More on what? Bigger objects. If the mass increases, the gravitational force also increases. And I said also gravitational force is also governed by distance. So this is what happens when it comes to distance, right? If the distance increases, right, the force of gravity now decreases, right? If the distance does what? Increases, their force of gravity decreases, it becomes lower. Are we together? Now, as I said that force of gravity is governed by mass and as well as distance, right? It brings us now to the issue of mass and weight, right? What is the difference? What is the relationship between mass and weight, right? First, let's define what weight is. So weight is the force in which the earth attracts on an object, right? So it has to do with the pulling force of the earth or applied by the earth in relation to the object's mass, right? Am I making sense? Now, it says weight is the force in which the earth attracts on an object, right? So mass now is the amount of matter that a substance consists of. It is the amount of matter that a substance is made of, right? And weight has to do now with the pulling force that is exerted by the earth on the object in relation with its mass. Are we together? So now, it is the heaviness of an object. Now we're talking about the mass of an object, the amount of matter which makes up an object, right? It is the heaviness of an object. So now, the relationship between mass and weight is very proportional, right? The weight of an object is proportional to its mass, meaning the greater the mass, the greater the weight of an object on Earth or on the moon. Are we together? So we notice that now mass and weight are different. They are different from one another, right? We're talking of different things. So as I've said, that weight has to do with what? The force of gravity acting on an object in relation to its mass again, right? So it is the product of the mass and the acceleration due to gravity. Are we together? So now weight is measured in newtons. So if we were to calculate for weight, this is our formula that we're going to use, right? We need to look for the mass of an object in kilograms multiplied by the acceleration due to gravity, right? The gravitational pull. Then to give us our weight of that particular object. Are we together? Let's look at this formula again, right? When looking for weight, it is we said that we're going to take what? Mass multiplied by gravity, right? So it is m multiplied by g, right? Where in this formula, our W is the weight that we're looking for in newtons. Our m, it is the mass in kilograms, the mass of an object, the heaviness of an object in kilograms. Then the g is the value of gravity, and we have 10 in brackets, right? So let me explain the 10 first, right? So the gravitational pull is what? Is 10, right? So now, it is 10 only when we are talking of Earth, right? The gravitational pull of the Earth. But it is different on the moon, right? The gravitational pull on the moon is 1,6. Are we together? So how can we find out the answers now in the different situations, right? We simply multiply what? The mass of an object by 10, but only if we're calculating for weight on Earth, right? And we have to give the answer in newtons. But if we're talking about an object that is on the moon, right? We're going to take the mass of the same object, but multiply it with what? 1,6, and it will give us our answer in newtons, right? 1,6 because the gravitational pull on the moon is 1,6 altogether. So let's just make a rough example, right? So we have a calculator here, right? Let's say a particular person has the mass of 60 kilograms, right? 60 kilograms. This is the heaviness of this person. This is the amount of matter that this person is made up of. And we need to calculate for their weight on Earth and on the moon, right? So on Earth, as I've said, we multiply it by 10. So meaning what? We're going to take, right? We're going to take these 60 kilograms, right? Multiplied by 10. It gives us how many, right? 60 multiplied by 10, it gives us 600 newtons, right? That is the amount of force in this person, or the amount of weight in this person where on Earth, right? So the same person visits the moon, right? When the same person visits the moon, right, the weight is going to change, but the mass of the person still remains the same, right? So it is 60 kilograms, right, multiplied by the pulling force or gravitational pull on the moon, which is 1,6, right? So it is going to be 60 kilograms multiplied by 1,6 to give us what? 96 what? Newtons, right? It gives us 96 newtons of force, and this is the weight of this person where on the moon, right? So now I hope we can get the difference between mass and weight, right? So now we said that this gravitational force now it acts between the Earth and the moon, right? So as it acts between the Earth and the moon, it keeps the moon in orbit around the Earth, right? They have that pulling relationship which keeps the moon in orbit and in position around the Earth, right? As you can see from our example here. But now the pull also causes what we know as tides, right? The gravitational pull between these two big bodies causes what we know as tides, right? So the pull between the Earth and the moon causes tides, right? By the moon exerting a pull force on the oceans. Tides now are those waves on the oceans, right? It is caused by the gravitational pull on by the moon that is exerted on the Earth, and it causes these pulls on the oceans. Hence we have waves like this, right? So the Earth is also pulling on its side, and also the moon is pulling. Hence we have these waves, which is these waves that we call what? Tides, right? And please note that the motion of all objects in the universe, they are governed by gravity. So now, enough talking. We have activity one, right? Activity one is what we need to write and test our knowledge so far, right? So let me go through the questions with you now. Number one is saying explain the difference between weight and mass. Whereas number two says calculate the weight of a person who has a mass of 120 kilograms A on Earth and B on the moon, right? The same person having a mass of 120 kilograms, right? So I'm going to give you 5 minutes to complete this activity. Then after that, we shall mark the work together. Welcome back again, grade 9s. Now let's do the corrections together. Number 1, explain the difference between weight and mass, right? So weight is an indication of the force of attraction that the earth has on an object, whereas mass is the amount of matter that an object consists of, right? That is the difference between weight and mass, right? Remember, weight has to do with the gravitational pull and its relation to the object's mass. Then number 2, calculate the weight of a person who has a mass of 120 kilograms, A on Earth, right? So here we have the formula. When looking for weight, we say what? Mass multiplied by gravitational force, right? So the answer is here, it is 120 kilograms multiplied by 10 to give us what? 1,200 newtons, right? That is the weight of this person on Earth. So for the same person on B, but the person is on the moon now, right? It is 120 kilograms multiplied by 1,6 of gravitational pull to give us 192 newtons of force where on the moon, right? So I'm going to give you another quick minute to copy down these corrections. Then after that, we shall continue together. And please don't forget our WhatsApp number. It is 079-578-2908. Let's continue after a minute. Welcome back, grade 9s. Now let's continue together with our lesson, right? So we have wrapped up one example of our non-contact forces, which was gravitational force, right? So now I want us to look at electrostatic forces as one of the examples as well. So now electrostatic forces and magnetic forces are the only forces that can both attract and repel, right? When talking about attracting and repelling, we're talking about pushing away from each other when it comes to repelling, and attracting, which means what? Pulling closer to each other. Are we together? So electrostatic forces now, they act between charged objects, right? Between charged objects or particles such as electrons or protons. So just a reminder, right? We said that all matter is made up of atoms. And these atoms are made up by subatomic particles such as the negatively charged electrons, the positively charged protons, and as well as the neutrally charged neutrons, right? So now, when there is friction between objects, right, there's some jumping and jumping of electrons, where the one object loses electrons and the other one gains these electrons, right? So that's what we're going to talk about in this section. So now, note that neutral atoms have equal number of protons and electrons, meaning they have the same number of protons and electrons, right? But during friction now, when two objects are rubbed against each other, right, energy can be transferred to the electrons and cause them to move from one substance to another. Where now you will have what? This substance that loses electrons becoming what? Positively charged, because now it has more protons than electrons. And the other one that gains these electrons becomes negatively charged, right? It becomes negatively charged because there's more electrons than protons. Are we together? So now, When two objects with like charges, right? Let me start with unlike charges, right? Because I've talked of negative and positive, right? So when two objects of unlike charges come closer to each other, they will attract. By unlike charges, I mean that the other one is positively charged and the other one is negatively charged, right? So positive and negative, they do what? They attract, right? There's some pulling force between them, right? There's some energy between them. But when two objects with like charges are near each other, meaning they have the same types of charges, it's either they are both positively charged or both negatively charged, right? They will repel, meaning they will move away from each other. Are we together? Let's look at this illustration as an example, right? So you have two balloons here, right? One is, four balloons. Two are positively charged and two are negatively charged, right? So look at the ones in between, right? They are of different charges. This one now is positively charged, whereas this one is negatively charged, meaning there's more electrons than protons, right? So they're going to do what? They're going to attract. There's going to be the force of attraction here because of what? They have different charges. They are of what? Unlike charges, right? One is negatively charged and the other one is positively charged. But now, objects of like charges, both they are either positively charged or they are either what? Negatively charged. They are going to repel. They're going to move away from each other. Like these two, right? They're going to repel, right? And these two also, they're going to repel. They're going to push away each other or move away from each other, right? So quickly, let's move on to magnetic forces, right? So when talking about magnetic forces, right, we're talking about a force that is exerted over a distance by magnetic materials, right? So now, magnetic force, right? Magnets also exert a non-contact force on other magnetic materials, right? So only three metals are magnetic. Those metals are iron, cobalt, and nickel, right? Those are the types of metals that are magnetic, right? That they can be pulled closer by magnets over a distance, right? So it means what? Any compound, right? Any compound containing one of these metals can also have magnetic properties, right? So the area around the magnet in which other object experiences a force is known as a magnetic field, right? So looking at this example here, right, we have a magnet pulling what? A tin closer to it from a distance, right? From a distance, right? This is because what? The tin is magnetic as well, right? So the force is able to act and the magnet is able to pull the other object closer to it because of what? Of its properties. Are we together? Right. So as we said that a magnetic force is a force that two magnetic materials exert on each other over a distance, right? It is governed by a magnetic field. It acts in a magnetic field, right? Which is an area around the object or the magnet, right? Where the force starts to act. Are we together? So looking at our magnet here, right? It has what? It has a north and a south pole, right? And it has a magnetic field around it, right? Which is the area where now the force can start to act, right? Meaning other magnetic materials can be able to be pulled closer from this distance, right? Or from this surrounding of a magnet. Are we together? So magnetic objects also have magnetic fields around them, as I've said just now, right? So looking at this example again, right? So here we have a magnet, right? So probably this spanner, if it was at this point here, right? It was not going to be able to be pulled closer to the magnet because of what? The magnetic field is far from it, right? Both magnetic fields are far from each other, right? But because now it is closer at this point, right? And all magnetic fields are they are closer to one another, this force is able to act, right? This magnet is able to pull this spanner closer to it because of the both the magnetic fields on these two objects, the magnet and the spanner, right? So also we have activity 2, right? So now, number 1 of activity 2 says, what is the difference between electrostatic force and magnetic force? Number 2 says, identify the size of gravitational force, right? So A, if Abigail answers her cell phone, what happens to the distance between her and the cell phone as compared to the distance between them when the cell phone is placed on the table? Right? So I'm going to give you 3 minutes quickly to copy and complete this activity. Then after that, we shall mark together. Welcome back again, grade 9s. I hope you enjoyed this activity. Now let's look at the solutions together. Number 1, what is the difference between electrostatic force and magnetic force? Right? So electrostatic force is the field force that arises through differences in electric charge of objects, right? So objects need to undergo friction, right? To also for the other one to lose electrons and the other one to gain electrons, then you have different charges, right? Then magnetic force. It is a force that two magnetic materials exert on each other over a distance, right? That is the difference. So now, number 2, identify the size of gravitational force, right? So if Abigail answers her cell phone, what happens to the distance between her and the cell phone as compared to the distance between them when the cell phone is placed on the table, right? So remember our section where we talked about the size of gravitational force, right? So what is going to happen here? The distance decreases, right? The distance decreases. Are we together? So I'm going to give you a quick 2 minutes to copy down the corrections. Then after that, I shall give you a chance to flood in our WhatsApp with your questions, comments, or anything regarding this lesson. Welcome back, grade 9s. Now let's move on to our WhatsApp questions slide, right? So now I'm giving you the platform to ask anything, to comment regarding this lesson, or tell us anything that is related to this lesson, right? So I'm going to give you a quick 5 minutes to flood in our WhatsApp with your messages, your questions, and comments, right? Let's meet again after 5 minutes. And if we don't have any questions, we are just going to summarize our lesson for today. Then we call it a wrap. Welcome back again, grade 9s. Now it seems like our WhatsApp line is empty, right? We didn't receive any questions or any comments regarding this lesson, so we are simply going to summarize what we have learned for today, right? So today we're talking about non-contact forces, right? So the difference between non-contact forces and contact forces is that the contact forces, the objects need to be in contact with one another for the force to act, right? They need to touch each other for the force to act. But with non-contact forces, it is the opposite, right? They produce their effect through space, they act over a distance, right? Without the objects touching each other, right? And these non-contact forces, they are also called field forces. And examples of these non-contact forces are gravitational force, magnetic force, and also electrostatic force, right? So talking about what? Magnetic force, we said that magnetic force, it happens between two magnetic materials, right? Magnetic materials acting what? On a magnetic field where they are able to pull each other closely, right? Then electrostatic force, right? It happens because of the differences in electrical charges of objects, right? When another object is negatively charged and the other one is positively charged, there's going to be the force of attraction between these two objects, right? There's going to be some force of attraction in the form of electric discharge or contact, right? And as well as gravitational force, right? Gravitational force, we said that it is a pulling force exerted by the earth on all objects on earth, right? It pulls everything down towards the center of the earth. So these are the examples that we explored in today's lesson. So let's meet again in the next lesson where we'll be talking about electric cells, right? So you know what to do now. You go home, right? You open your textbooks, you do your research on electric cells, right? Make sure you have some information before we come back here so that it is an easy process of teaching and learning when we get here, right? So from me to you now, thank you and goodbye.